So, we just learned about the two special right triangles, the 30-60-90 triangle and the 45-45-90 triangle. And we also learned about the ratio of their sides. Now we're going to prove why the ratio of their sides are like that. So, for this, we're going to need some knowledge of isosceles triangles. Now let's draw an isosceles triangle. So in an isosceles triangle, we know that their angles are equal. And we are going to mark it like this. And in isosceles triangles, because these angles are equal, these side lengths are going to be equal. And also in an isosceles triangle, if we drop a perpendicular or draw the height right here, this will also be a median. So these two segments will be congruent, and it'll be an angle bisector. And vice versa, if we drop an angle bisector from here, it'll be a perpendicular and a median. Same for medians, obviously. So that's all we need to know. We're going to draw an equilateral triangle. So we know in an equilateral triangle all the angles are congruent and the sides are also congruent. So let's label them all X. We know an isosceles triangle is a triangle with two congruent base angles. So here we see that these two base angles are congruent. So if we drop a perpendicular like this, then these two sides will be congruent and these two angles will be congruent. And these are both right angles. So what would we get? If these two angles are congruent, then they must both be half of the original angle, which is 60 degrees. Because the angles of an equilateral triangle are all 60 degrees. So 60 degrees over 2 is equal to 30 degrees. And obviously these angles are still 60 degrees. So we have two 30-60-90 triangles. And also, these line segments over here, this side, they're both equal and they all add up to x. So they both must be x over 2. Now we can use the Pythagorean Theorem to find this final side. I do have a video on the Pythagorean Theorem. If you want, you can go check that out. So, we know that this is the hypotenuse. So, these two sides squared must add up to the square root of the hypotenuse. X over 2 squared plus, we're just going to write a question mark, is equal to x squared. So let's bring this over to this side. We have x squared minus x squared over 4 is equal to what we want to know, squared. Well, x squared is equal to 4x squared over 4. So now we can finally subtract these two fractions. This would give us 3x squared over 4 is equal to the square of what we want to find. And taking the square root of both sides, what we want to find is equal to x root 3 over 2. So that proves the 30-60-90 triangle. Now let's go to the 45-45-90 triangle. This one's a bit more straightforward. Let's just draw a 45-45-90 triangle. Okay, let's pretend this is a right angle. And these two sides are congruent because if these angles are both 45 degrees, this is an isosceles triangle again. So these sides must be congruent. So we can label these both x, and if we use the Pythagorean theorem to find this other side, once again, You can go check out my video on the Pythagorean Theorem if you don't know it. We have x squared plus x squared. This time we'll just label this side y is equal to y squared. So 2x squared is equal to y squared. And if we take the square root of both sides, we see that x root 2 is equal to y. So this side must be x root 2.